So this question was asked in GATE 2012 CSIT paper. A file system with 300 GB disk uses a file descriptor with 8 direct block address, 1 indirect block address and 1 doubly indirect block address. The size of each disk block is 128 bytes and the size of each disk block address is 8 bytes. The maximum possible file size in this system is. Hey guys, I'm Pratik. Let's solve this one. So like always, just see what is given in the question first. So in question it is mentioned that they are using 8 direct block addresses, then there is 1 indirect block address, then there is 1 doubly indirect block address. Then we know about disk block size, which is 128 bytes and the disk block address is 8 bytes. So that much information we have, and we have to find out the maximum possible file size by using the system. Okay, so let's find out then. So before solving further, let's find out that how many addresses or how many disk block addresses we can accommodate in a single block. Okay, because each address is pointing to a particular block, so we have to find out that how many disk block addresses we can accommodate in a single block. Okay, so the number of block address in each block will be, we have the block size which is 128 bytes and then we know about the disk block address, okay, which is of 8 bytes. So when we solve this we will get 16. So from this we can say that in each block there are 16 block addresses. Okay, it means if we are indirectly pointing through that disk block, then that single disk block can point to 16 disk blocks. Okay, because in a single block there are 16 disk block addresses. So there are 16 block addresses in each block. Okay, so let me show you the scenario so that you can understand it well. So suppose that we have a kind of memory. Suppose that this is a memory and here we have 8 disk block addresses. Okay, and as I told you, each disk block address is pointing to a particular block. Okay, and we have 8 disk block address, so they are directly pointing to a particular block. Okay, so if we use such system, then we will get, as the block size is 128 bytes, and if we use such system we will have 8 into 128 bytes of memory. Okay, and now we have one indirect block address. So let me show you that how indirect address works. So here in indirect block address, it is first pointing to a particular block. Okay, we just find out that in each block there are 16 block addresses. Okay, so first it is pointing to a particular block which is having 16 block addresses, and then each address from that block is pointing to a particular block again. Okay, it means that we have a block, and in that block we have 16 block addresses, and these 16 addresses are pointing to a particular block again. Okay, so if we use one indirect block address, we will have 16 into 128 bytes of memory, and then we have one doubly indirect block address. Okay, so it's like it is pointing to a block first which is having 16 block addresses, then those 16 addresses are pointing to a block again, and in those blocks there are again 16 block addresses. Okay, and then they are pointing to a blocks. Okay, and if we use double indirect block address, we will have 16 into 16 into 128 bytes of memory. Okay, it's like first a particular block is pointing to 16 blocks, and each block of those 16 blocks are having 16 block addresses again. Okay, and each block again pointing to 16 blocks. Okay, and when we compute this, we will have 16 into 128 bytes of memory. So if we use this kind of system, then the maximum size of file system will be 8 into 128 bytes, which is from 8 direct block address. Then there is 16 into 128 bytes, which we got from using one indirect block address. and then there is 16 into 16 into 128, which we got from using one doubly indirect block address. Okay, and when we add all this stuff, we will have 350840 bytes of memory, which is equal to 35 kilobytes. So the B is the correct answer.